Hello everyone, my name is Ronan. I work at the Colony Public Library. I'm kind of the resident science enthusiast here, and today we're going to do more fun experiments and learn more about chemistry. I hope you've seen our other two videos on chemistry and the other experiments we did, but just in case you didn't, let's do a quick review. So we're learning about chemistry today. Do you remember what that means? That means it is the study of matter. And what is matter? Matter is anything that has mass or weight and takes up space. And we learned about two different types of ways we can change matter. We learned about physical change and chemical change. So physical change is when we move the substance around, we move the molecules of the substance around, we change states of matter, we make it float or sink, we change the temperature, things like that. But the main thing is that we can easily change it back to whatever state it was before, and we don't change the substance itself into a new material. So like solid water turning into liquid water and turning back into solid water, things like that. And then we did a chemical change experiment. So chemical change is when we start off with one substance, we have a reaction, and it turns into a different substance, and we can't change it back to what it was before. So with our previous experiment, we did baking soda and vinegar. So that had a chemical reaction, and it turned into carbon dioxide. And we also experienced an endothermic reaction, if you remember from our video. That means that the reaction was cold. It was absorbing heat, and it felt cold to the touch. So we're going to do a different experiment and see and compare it to our other experiments and see if it was a physical change, a chemical change, or what else happened with it. So are you ready to get started? I'm really excited, so I hope you are too. And be sure to have an adult with you when you do this. And also this one might get a little messy, so we have a baking tray to put this on. Maybe if you have access to outside, you can do this outside. It'll be safe, it's not gonna like hurt anything, but it does get a little messy, so just be a little more prepared for that. All right, you ready? All right, let's get started. Okay, so for this experiment, we'll need a plastic bottle. So this could be from a water bottle, or if you have a big 2-liter size bottle, that will work even better, but it's okay if you just have a little guy like us. We need some hydrogen peroxide, a cup to put it in, a funnel to measure it with, and a measuring spoon to pour it in, or to measure it with. So we need specifically 1/2 cup measure. We also need food coloring and some yeast. So if you have packet yeast or bulk yeast, either work. We're going to use the packet yeast, and some warm water. So this can be just from your kitchen sink, warm like what you use to wash your hands. It doesn't have to be boiling or anything. And a cup and a spoon as well. Oh, we also need dish soap. So first, we're going to use the dish soap and just kind of coat the bottom of the bottle. So just pour enough so that it fills the bottom of the bottle. Okay, and then we're going to measure out the hydrogen peroxide. So remember, we need 1/2 cup. 1/2 cup of hydrogen peroxide. Let's be sure not to spill. We also have this baking sheet to kind of keep our station clean, because this will be a messy experiment. Okay, let's put our funnel in the bottle, and now it's time for our hypothesis. Do you remember that word? So a hypothesis is a scientific guess. So what do you think will happen when we put the hydrogen peroxide inside the bottle with the dish soap? You can write this down, you can tell someone that's with you, you can keep it in your head, either way, but let's think about what will happen when we add these two materials together. All right, do you have a hypothesis? All right, on the count of 3, are you ready? Let's mix the peroxide with the soap. 3, 2, 1. Nothing happened, whoa! No, okay. So that wasn't the full experiment, we're not done yet, but there is actually something happening. It's just going really, really slow. So we want to speed up this experiment, right? We want to make it more exciting. So this is when the yeast comes into play. Do you know what we use yeast for in like regular everyday life? We use it to make bread, usually. So yeast is actually alive. That's really interesting. It's kind of like a fungus, like a mushroom sort of, really small fungus. And what it does is when it's working all together, they're hanging around, they're eating, but they're also kind of burping. And that burping creates a gas, a carbon dioxide gas. That's the same gas that we exhale. And so that gas is what we use to make bread, and that's what makes bread rise and get all fluffy and has those holes in it. And we're gonna use this yeast to help make this reaction go faster. So this is a catalyst. A catalyst is when something is added to a reaction to make it go faster. So that's what we're gonna do with our yeast. So I'm going to use the packet yeast. We're going to use 1 full packet. If you have bulk yeast like this, you can use 1 tablespoon. I'm just going to open up this packet and use that. Let's pour it in its own little cup. So remember I said yeast is alive? Right now, it's kind of like asleep. So we need to wake it up. So let's add some warm water, just kind of enough to coat it all. Whoa, that was a little too much, that's okay. So right now we need to wake it up. Wake up, yeast, time to do some work. So you take a little plastic spoon and get it all stirred together. Just stir, 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 stir. Wake up, yeast. It's time for you to do some burping. All right, get it all nice and stirred and waked up. That's not a word. All right, next what we need to do is add some food coloring. This is just kind of for fun. It doesn't really affect the experiment, but it's fun. So I'm gonna take this food coloring and I'm gonna drop one drop to the side and it kind of falls down the side. I'm gonna turn the bottle and put another drop, kind of 90 degrees. So we're gonna put 4 drops, so 90 degrees, 90 degrees, 90 degrees. Turn it again, put another drop, boop, falls down the side. One last drop. So we have 4 drops around the side of our bottle. All right, now it's time to add our catalyst, our yeast. It's all woken up. All those little fungus is waking up and they're gonna start burping and make this reaction happen faster. So we're gonna do another hypothesis because now we're adding another material to our experiment. And also be sure your sheet is all clear. So do you wanna make another hypothesis really quick? What will happen when we add the yeast to our peroxide and soap mixture? Do you have a hypothesis written down or in your head? All right, on the count of 3, let's add this together. 3, 2, 1. Take that out. Whoa! There we go. Oh my gosh, that's so exciting. What happened? It's still coming out. Wow, that is a lot. All right, what happened? This is so crazy. So it made a lot of bubbles and it exploded up and kind of spilled out everywhere. So that was a really exciting reaction. So what happened was, remember that yeast is a catalyst and that yeast makes carbon dioxide. But what happened was, not only was it making carbon dioxide, but hydrogen peroxide, which is H2O2, that sounds really similar to water, right? Which is H2O. So naturally, hydrogen peroxide kind of disintegrates into H2O, which is water, and O2, which is oxygen. So this bubble mixture is a mixture of oxygen and carbon dioxide, mostly oxygen. So what did we start off with? Do you remember? We started off with hydrogen peroxide, we started off with dish soap, and with yeast. Do we still have all those materials? It looks like we just have a bunch of foam, a big old mess. So all that foam means that there's a gas, right? O2, oxygen, as well as a little bit of carbon dioxide. So can we put that oxygen and carbon dioxide back in the bottle and make hydrogen peroxide and soap again? Probably not. So we have a chemical reaction, right? A chemical change. We started off with one substance, we ended up with a separate substance, a completely new thing, and we had a really cool reaction. We also want to kind of feel the bottle really quick. We want to also not try and touch the peroxide. It can dry your hands out. It's okay if you do accidentally do it, but let's try and find a dry area and feel the bottle. What does it feel like? It feels a little warm. That's interesting. Kind of like our other reaction in a previous video, it was a cold reaction. This one is a little warm. So if you remember, that other reaction is called an endothermic reaction when it felt cold. This one is warm. That means it's an exothermic reaction. So in this case, it's like the heat is exiting the reaction and it feels warm. So this is another indication of a chemical reaction. So we have 2 indications. We have a new substance, in this case oxygen, in all those bubbles, and a warm reaction. So that means that we had a chemical reaction on our hands. Well, that was a really fun, exciting experiment, right? We made a kind of a big mess, but that's why we kept it safe and secure in our tray. And this can be cleaned up easily. We can just clean it out in the sink and it's totally fine. So I hope you had a lot of fun doing our experiment. I hope you wrote some stuff down, made your observations and your hypothesis, and I hope you come back for our other experiments we might have in the future. Bye!